Okay, welcome back. This is the beginning of section 2 of Unit A in Biodiversity for Science 9. The last section we learned that there is a wide array of species, different populations with different species, that there are variations among ecosystems, and there are variations within a species. For example, giraffes. Some giraffes have longer necks than others. That's a variation within the species of giraffes. We also learned classification. There is a system of classification used to organize animals, not just animals, but all living organisms, with respect to how many traits they share with one another. We start with the broad category kingdom, which we have a lot of living organisms that don't share a lot of traits that are similar, and then we go all the way down, right down to the specific species of which there are limited numbers, but share quite a number of characteristics. We also learned that there are interspecies competition, where species compete. Different species, I should say, compete for scarce resources like food, access to water, access to space for living conditions. We also learned about resource partitioning, where competition is actually decreased because organisms um, that compete for similar resources have sort of figured out a way to divvy up the resources that exist there based on just little micro niches where they find these resources. The example was of the warbler. So some warbler would just hang towards the top part of the tree and get their seeds there, while other species of a similar species of warbler would gain access to the seeds that they need more on the ground. And that's resource partitioning. We also tackled a pretty big concept that will keep coming back over and over again for any of you that are going to go on and study biology in high school and beyond. It's natural selection, which is summarized in the pretty popular saying, survival of the fittest. Well, I always say survival of the fittest, but with the caveat of adding that is the survival of the fittest for a particular environment, because it's all about the environment and the pressures that the environment puts on a species of organisms to put some traits at a selective advantage over others. Now, with that being said, if there is a selective advantage for certain traits, then that trait will most likely, in fact, will be how could I say this? It will be passed on to the next generation. Okay? So now what we're going to do is we're going to turn our attention to what characteristics get transmitted between generations. And we have both heritable and non-heritable characteristics that we are going to consider. So here are your learning outcomes. You can go ahead and pause the video briefly to just read those. Heritable characteristics, these are the characteristics that are passed down from generation to generation. So for example, eye color, the hair type, the skin color. You notice these birds have a certain color. They're passed on to the next generation. Here, more or less the same sort of thing. The different traits, because they are heritable, are passed down. Non-heritable characteristics are what are acquired. These are traits that are not passed down. So for example, in this picture, you don't pass down purple hair, right? So therefore there's nothing in the genetics for it, so it's not going to be passed down from generation to generation. Okay, these are some more examples of non-heritable characteristics that might define a person. So for example, if you're not born being able to play the piano, that's something that you learn over time. For example, as well, we're not born knowing how to swim. It's something that we learn over time. Okay, we get our characteristics primarily from our parents, the ones that are inherited. But we have to consider that there's something called an inherited predisposition. Okay, in other words, there's a difference between predisposition and being able to do something. You might be predisposed or born perhaps with an athletic ability. Okay, so you might be the type of person just, you know, has a natural predisposition towards being a good athlete, but you're never going to be a good athlete, for example, if you don't play sports, right? Um, and then this one here is a very good example as well for music. So that's the difference between inherited and non-inherited characteristics. With respect to the inherited characteristics, there are two main kinds of variations that we need to talk about. There's discrete variation and continuous variation. And what these mean, you can kind of think of is just discrete variation is going to be pretty much an either or type of variation. Okay, so you have definite characteristics of inheritance. So, for example, we have a picture here of Gwyneth Paltrow who's got blue eyes. So she has blue eyes. She doesn't have brown eyes. She doesn't have green eyes. She's got blue eyes. That's a discrete trait. You either have it or you don't. Okay. A continuous variation is more like height is a very good example of a continuous variation. So this is a very nice diagram here where, let's say on this side here we have, let's say a short person, and on this side here we have someone that's tall. But if you look at all the people in a single population, it's not like you have either short or tall people. You have short people, and then kind of in the middle you got average sized people, and then you get less taller people, right? So that's the kind of thing that happens with continuous variation. It doesn't fit into a nice this or that category. You have a range of types within the middle. So here we have a short person and a tall person, but in between these two heights we have many other people with varying heights. Okay, we talked about eye color. It's either blue or brown, for example, and we'll talk about dominant traits in the next section. Okay, this just talks a little bit more about that. I'm not going to talk too much about this. Another example of inherited characteristics that are discrete variation are earlobes. Some earlobes are attached, okay, and then other people have earlobes that kind of flop around and that they're unattached earlobes. Okay, so continuous variation, we talked about this slide already. You can pause it if you want to read it a little bit more. Okay, there's a picture that says it all. But once again, height is not a discrete variation. It is a continuous variation. This is a picture of a gentleman that has a disease called acromegaly. And acromegaly is just an endocrine disorder where you have the release of growth hormone in excess quantities, so the person doesn't stop growing, and so they have this. Acromegaly is also known as gigantism, and there have been some popular people with it, namely Andre the Giant and some others. Mass is another one, a very good example of variation. So notice that we have extremes here and here, but in between we have this variation, this the existence of several different body types when it comes to mass. Okay, the environment does play a role, though, we have to consider. So some interactions with the environment can also affect the physical traits of somebody. So for example, if someone eats consistently junk food, or eats junk food consistently, they may lean towards gaining more mass, more weight. Okay, so for example, if you take two plants, this plant was grown in light, so there you go, you have nice development, and this one was grown in the darkness. So the environment does play a role in the expression of these physical traits. Okay, so North Americans are taller. A big one, generally speaking, is because of nutrition and access to a wide variety of foods. If you have access to a wide variety of foods, you have access to a wide variety of nutrients that you need. Okay? So for example, if mom and dad are both tall, chances are a child will grow up to be tall. However, if the child does not receive adequate nutrition, then he or she will not fully develop their height. And that's about it for discrete and continuous variation of heritable characteristics and comparing that to non-heritable characteristics.